Right, perfect. Can you see my screen, right?
Yep, all good.
All right, okay, excellent. Hey, everyone. Thanks for having me for this session. Usually, when I go to serverless days, there will be one Kubernetes talk surrounded by a bunch of serverless talks on AWS and things. Whereas today, I am kind of sandwiched between two Kubernetes talks. So I hope I will survive. Let's see. My name is Sheen Brisals. I'm an engineer by trade, but my title now is Senior Engineering Manager. Now, patents mean different things to different people. Now, there are tons of publications and books, and if you've been through the industry, I'm pretty sure you know the book at the top left corner, The Gang of Four, and there are a number of different definitions and the meanings for patents. So basically, the way I look at it is like it's a construct that can be used to get some momentum in our development. So that's sort of the common things that we can apply repeatedly to get things moving faster. And when it comes to the serverless world, people even call serverless as a pattern, and you hear number of new different kind of names being passed around to talk about patterns. So one way of looking at it is like on one side, we have all these sort of the traditional programming patterns like the facades or the singletons and those kind of things. On the other side, we have this the architectural patterns like a traditional ones or the new ones, things like the circuit breakers or the gatekeepers or the saga patterns and all those kind of things. But I look at it serverless patterns somewhere in the middle. So not fully into programming, but yes, we do take programming patterns and also a mix of architectural patterns. So that's one way of looking at the serverless patterns, in my opinion. And often when I talk about serverless patterns, sometimes when I show a particular use case or a construct, and people say that that's looks so simple. Is it really a pattern? Then I would say that yeah, what's wrong if it's simple, right? If it's simple, it's simple. Why make it so complicated? So that's kind of the good thing about the serverless and the patterns around serverless. Now, why am I talking about serverless patterns, you may wonder. So this is Lego.com. Now, we moved this Lego.com onto serverless last year. So the backend of Lego.com is completely serverless. The front end, which is based on React Node, it's on Fargate, and there is a GraphQL layer that is also on Fargate. So that's the reason why I'm here talking about serverless patterns and things. Now, the patterns I show are very simple use cases, and hope you should be able to follow through, even if you're not a AWS user or familiar to serverless itself. During our migration, we use number of AWS services. We roughly have around 200 Lambda functions in production and a bunch of other things like around 30 or around 40 microservices doing different things. So okay, let's move on to the pattern. So let me start with a simple request response pattern. This is a very basic thing. So if you take a use case, so if when you go online and when you do a shopping and you drag and drop a product or add a product to basket, right? So this is a simple thing that happened. As a user, you want to know whether it is succeeded or failed. It's slow, so sort of an atomic thing. So what we call is this atomic request response pattern. Okay, so this is a synchronous thing. So there is an either success or a failure. It's nothing in between. The front end or the client, which invokes an API, and most likely there is a Lambda function behind it serving the request and is doing a bunch of things, but comes back with a quicker response and saying that okay, it's good. Or if it failed, what's the reason? So this is a simple pattern. This is so common, you would have seen a number of places, but still a pattern because we kind of apply this again and again. Now, if you move it a little bit further, and then you do your shopping, you finish the shopping, you submit that order. At that point, usually behind the scenes, there are a number of things that happens. One thing is to negotiate with the payment provider to validate your payment and get the assurance and things, and also validations on your basket to do things like whether you have exceeded the limit, or are you allowed to buy this product in this country, and promotions, applying the promotions, bunch of things. So during this period, you don't often keep your client hanging on to that request, right? So what happens is, in this sort of event-driven world, it gets decoupled from the front end. So front end gets an acknowledgement, and then you open up a different mechanism, a querying or a status query mechanism for the front end to check how far the order is in, right? So this is another simple pattern which basically falls into this sort of common, the command query responsibility segregation area, where the first one, where you submit the order, you hit an API, goes through a Lambda, then decouples with a queue in between, then it does a bunch of things, going to the payment provider, or dealing with your commerce platform, and then you put a status in a cache or a DynamoDB table. Then the query mechanism comes in to help the front end to identify the status of the order. Now, I mean, this is not related to the pattern itself, but when it comes to reporting the status, it's so common that you separate into two different aspects, because but the backend, especially these services, when they deal with a payment provider, or when they deal with a commerce platform, the error situations, they get the details so granular. So they may get that insufficient fund, or is a stolen card, or whatever. But at the front end, you don't often expose all these sort of internal details to the client, because that may lead to, if there's a fraudster, that's kind of giving more clue. So in that case, you kind of separate that out into a different status level. So that's so common in these particular situations. So there is the development currently going on where it's to do with sort of batch processing, where thousands of transaction IDs, payment transaction IDs, can be submitted to an API. So in that case, a similar pattern comes into the picture, because you don't often hold the client until all the thousands of the transaction dealt with, especially to settle funds with the bank. So what happens is that the client gets an acknowledgement, then there is a status API that comes into action. The client will then look at, okay, how far it's been through, how many transactions been successfully dealt with or failed, and things like that. Right, let's move on to security patterns. Again, as I mentioned earlier, this is simple patterns, okay? And it's nothing complicated. So here is a use case we have. So we have loyalty customers. Often we give the loyalty customers the voucher codes. So there is a service that is in charge of generating thousands or even millions of voucher codes. So when that happens, it takes time. So we don't, again, hold the client. So client in the sense, not the end user client, this is business user or stakeholder with admin rights. So what happens here is that you process the vouchers, and then you send a secure notification to the admin person to download the vouchers, things, So this is another common pattern, in the serverless industry, that you hit the API, and it gets the, accepts the request, and you get a response back, an acknowledgement. Then the backend, the bunch of services, they swing into action to generate all the vouchers and store them in DynamoDB, because you need them for the validation later. Whereas if you want to supply the, the voucher codes, you probably store them in a file or something. Then you, send a secured, URL to the, the requester. Okay, so that's the, that has a limited validity period, so that only the person will get the URL, and they can download it, and off it goes. So this is kind of a simple secure pattern you often find, especially when you work with S3 bucket. And similar one is when you kind of do some validations as part of your API request or the authorization part. So again, if you're a loyalty customer, you are coming to the online shop, for example, and you want to know your account details or loyalty account details, for example. So if you look at it, in our case, so there are different identity systems come into picture. So if you are a signed in user, then you are definitely to have a Lego identity, what we call as a Lego identity. So you come in with that. Then when you work with a commerce platform, you have a different token or identity given, because the commerce platform keeps your loyalty number. But then when the request moves to the the loyalty platform, it needs to know that you are the person who say you are. Okay, so for that, what we have is commonly known as the the Lambda authorizer or the custom authorizer. So that is another piece of functionality that sits there on top of the API gateway endpoint to make sure that the person the credentials or the details coming in or belongs to this person, and where it is good to proceed, or not, if not good, then it will be rejected. So this is a common pattern. People call different names. Sometimes you hear this as a gatekeeper pattern or something. The beauty of this is that once you have this sort of setup with an API, it makes it easier to replicate or adopt this pattern onto different places. Of course, the logic may differ, but you kind of get that, the construct, so that can be easily implemented to achieve different things. Now, moving on to event-driven patterns. So, I mean, event-driven is a common word you hear all the time when you deal with the serverless. The reason I thought of adding it here is that often simple patterns enable you to achieve bigger things. Say, for example, in this one. So when we moved to the new commerce platform, we had this dilemma of we had millions of customer data. Now, the problem was, should we migrate all the millions of data to the new platform or not? Because good proportion of that, the data could be obsolete, because customers either created new profiles or customers moved on, and those profiles never get used again. So we took a bold step not to migrate, do the mass migration. Rather, we thought we will do an on-demand migration. So that's where the simple event-driven publish subscribe pattern comes in. It's so simple. I mean, if you are familiar with AWS, you would have used this SNS topic subscription mechanism many times. But these sort of simple patterns, the power they provide sometimes is, beyond imagination. In our case, what happens is that when a customer comes to a new platform, now we kind of log in with a skeleton customer profile. And as soon as that login happened, we receive a notification onto our topic that then triggers a Lambda function. And I mean, I know in reality, we have few other Lambda functions as well. They kind of, spring into action to do various data fetch aspects from the backend SAP systems and put that back into our, the new commerce platform. So it happens within, in milliseconds or within a second or so. Most cases, customers won't realize this happening in the background, because as they move on to the next page or checkout stage, they would already, got all their address or the other details in the system. So this is, the pattern is small, simple, but the power we can, extract from that is, as part of the architecture, could be substantial. This is another one. This is again a common thing, like the data pipeline. So in here, we have the SAP backend as the master data, and we have the commerce platform, which is a new platform on the other end. So every product update happens, or when SAP performs an order fulfillment, we need to update the stock, and we need to update product data, or new products. So all these feeds flow through, and we need to process that and take it to the new platform. So this is a simple sort of event-driven data pipeline. So if you think about it, so that the feeds are getting dropped into an S3 bucket. So that triggers a Lambda function. So again, event-driven asynchronous invocation. Now, this must happen as quickly as possible because we get thousands of feeds every day, and sometimes hundreds of feeds come in at the same time because SAP, they batch for 5 minutes before they dump everything onto the bucket. So this happens so fast. Then what happens is that the Lambdas that process those, they then push the data onto the process data onto a queue. And that then triggers another Lambda function, another event-driven thing, and then they update the platform. The reason why I showed this split is because having that SQS queue there, you can really adjust the the speed of the flow, because that the queue acts as the buffer. In certain pipelines, you want it to go faster, or certain pipelines it's okay to be slower. So you can adjust the the parameters of the SQS queue to give that sort of the flexibility. Now, the beauty again is that so here is the similar pipeline or pattern shown in 3 different pipelines, and because all those 3 different pipelines handle different types of data feeds. In reality, in our production system, we have around 20 different pipelines exactly like this. Okay, so that is one pattern. When we proved it's working, it is a matter of just a simple copy paste kind of mechanism to have this going. So that sort of gives that much of the velocity to get something out quickly. It really helped. This is one of the the oldest patterns we came up with, and it really proved so useful as part of our migration to serverless. Now, functionless pattern, this is probably one of my favorites, because this is about writing less code or writing less function and making use of the platform enabled integration things to get something working. So this is event ingestion or event streaming pipeline. This is common behind every website out there, because this is what we call the clickstream events, right? So number of events flow through an API through a ingestion pipeline, go to a data store, and invokes certain processes and things like that. Now, if you look at the architecture of the AWS side of things, so you may come up with this sort of initial design. So there's an API, there's a Lambda function which receives the event and then puts into the Kinesis stream, and there's a bucket, so on and so forth. But if you think about it, if you are not doing anything with the data, that function is actually not necessary at all. So you may as well go with the direct integration of API gateway with the Kinesis. Then it goes to the bucket, and there's another Lambda get triggered. And the last part is actually another pattern you will hear in serverless world, is the fan out pattern, because one Lambda fanning out multiple other Lambda functions at the same time. So this is again a codeless the pattern. So there is no function, because every function or every Lambda function you can reduces so much of the the things that you need to do in terms of development or testing or deployment and all sorts of things. I wrote a blog post about the functionless aspect. There are a number of ways we can reduce the use of functions, and there are a number of new services like EventBridge that helps to achieve this. And the other one is along the same lines of the functionless is it's so common in many cases that you need to often generate numbers or registration numbers or order numbers. So that the sort of sequence number generation is kind of a bit tricky in the serverless world, because if you're from the traditional RDBMS and Oracle database, you know that it's so easy to get a sequence number out of the the database, whereas here it's slightly different. So here we can use the DynamoDB's atomic the integer option. But again, the thing that I want to show you is that the API gateway to the the DynamoDB in this case, it's without any function acting as the mediator. So that's another good thing about things. So if you look at the script for generating or the instructions, it's so simple. It uses the DynamoDB's the atomic integer counter feature. Now again, I wrote something about the same thing, and it basically explains the same thing in detail, how we can achieve this. Moving on to scheduler pattern. I mean, this is again, as we saw with the publisher subscribe. This is a common. This is a cron job. Okay. Again, the reason I added here is that the capability that you can make use of with such scheduler jobs, it can be very really useful. So in this case, so there's a timer which invokes a process which reads data from our commerce platform and generates catalog feeds to send out to search engines or for other teams or things like that. So it's again very common and very, very simple to set it up. The one thing I want to show here is that it triggers a step function in this particular case. And that step function is basically doing what we call in the AWS world is the dynamic parallelism. What that means is that, say, for example, if you want to generate the product feeds or catalog feeds for, say, 50 countries, you don't need to hit your commerce platform 50 concurrent or parallel queries, because that may be serving production there, the live traffic or the checkout traffic. So you probably you would want to be a bit smoother on this one. So with the dynamic parallelism, we can even that out. So we can say that, okay, let's do 5 in parallel, and then so it takes 10 iterations or things like that. So same way, it really helps. I mean, this is a simple case I'm explaining, but when you have hundreds of things, that really makes it easier to maneuver. So that's one of the reasons why I added it here. So this is same thing in a different view. So the middle part there, the get country feed, is that sort of the dynamic parallelism part of the entire state machine. All right, so let's move on to the final pattern. So event bridge pattern is not a pattern, event bridge pattern, because event bridge is a service. I can talk. I do a completely separate full talk on event bridge, because there are a number of patterns we can talk about with the event bridge itself. So here I'm just going to focus one pattern. So here is again an order flow. So order is placed and that needs to be shipped. Now, if you are a loyalty customer, then you want your orders to be shipped, and also you want your loyalty points updated. So those orders, need a separate, special treatment, for example. So this is something can be achieved easily with a sort of an event bridge these days. Now, it offers the so-called the hub and spoke event, bus pattern. If you're familiar with this, I mean, this is showing a simple thing. So on the left, you have the checkout microservice that is sending an event to the bus in the middle, and then there are multiple subscribers. So in this case, there are 2 subscribers. They work with the different filtering patterns to get the data they need, or get the event they need, rather. So here is the event data coming, and when it goes to the bus, and we set up the routing rules, and in there you look for in the shipping case, it is looking for all the submitted orders. Whereas when it goes to the loyalty update service, it's looking for all orders with a certain specific thing in it. So in this case, it's checking if you are a loyalty customer or something like that. So there are a number of different ways we can configure the routing rules and the filtering things and patterns and things, and with the event bridge. So that's why I said it's a completely a whole new thing that you can talk about all day. So I wrote a blog post as well if you want to know more about how these patterns and things play out. It's a really cool service which is gaining popularity. So that's kind of pretty much with the pattern. So let me close with why serverless and how serverless. So I know this usually I start my talk with why serverless and things like that, but been through the pattern. So now if you are new, just to give you ideas why serverless. I mean, you might have heard number of different definition of serverless and etc. So here I take a different view. So why serverless? It's because it's not just a Lambda functions. It's a number of other services coming together to give us the solution. So that is the beauty of serverless. I mean, there is still this misconception that, oh, serverless means a function as a service or Lambda function. I think it's slowly changing now, but still people think in that way. So it's so important to realize that it's not just Lambda function. You can have a serverless service without any Lambda function actually, because there are a number of other services can provide a service. Now then the beauty here is that this allows the granular level optimization. So you can tune two different Lambda functions completely differently depending on the needs, for them to operate. And the same way, if you have, say, an SQS queue, one queue can be tuned from the other in terms of the, the visibility or the timeout and things like that. So that is so cool. Even within one particular microservice, you can tune many things in different ways. How, that is the, the power of the, the beauty of serverless. And then it's ideal for iterative development in the sense that you don't need to start with a big bang and a big setup and everything together. I usually say this: you don't need to wait for all the stars and planets to align in order to do serverless. So you can just start doing something, and you can keep on, building on top of it. And then the engineering diversity. This is again, you don't see your engineering team or engineers as simply as a programmers, because they grow to learn many things. They need to know about security. They need to know about how the queuing mechanism work or the event-driven works, and also they get involved in the DevOps and all sorts of things. So these sort of the ownership and everything comes together. So that really helps to elevate the engineering teams to a different level. And then how to do serverless. This again is a, the so many things I talk usually in detail, but it's a summary of things. Now, as I mentioned, look something, if you're someone new listening, or you want to start serverless, start something simple. Look for some simple thing to, get grip with. Then from there, you can easily, grow. And yeah, as I mentioned, work with a solution first. Don't try to perfect it and apply all the different best practices and things you find on these blog posts and talks, but something simple to start with. Then as you move forward, you can always make it better and better. And then if you are doing things better, incorporate all the required tests. And separation of the accounts is important. That will remove so much of a hassle. You don't need to tag with all this and that and thing. It also give a freedom for you to set up the permissions from dev to prod and etc. etc. And architect in set pieces, this is one of my catchphrases. What I mean here is, with serverless, you architect and develop in small chunks. You don't need starting with your first brick to the last brick to finish the model. You kind of build parts of it, and you can experiment that running in your cloud environment to make sure it's perfect, tune it, and slowly bring things together. Because especially when we work with the event-driven and decoupled to the architecture, this really makes it helpful. And this is my own thing. So these days, with all the tools and technologies we have, we don't need to go back in the the 80s or 90s when we used to do a POC and throw it away. So it's many ways, if possible, you can start with your POC with a production thing in mind, and you can start building on top of it. Because if you think about it from AWS or another cloud provider point of view, the development environment and production environment basically the same. These separate this way, but for a cloud provider, it's just the same environment. So you can do your POC in your the QA or test environment one day, you make sure it works, and you can easily take that as to MVP to a production environment like the next day. And finally, leverage the patterns, because there are a number of patterns, a number of goody things around. I talked about small things. There are many big things. Currently, there is an implementation we're doing where we implement the Saga pattern for a particular reason. So there are a number of things. So understand and evolve the pattern. So you may come up with the new patterns yourself. So, that's the beauty of serverless, and that's the beauty of sort of the development process that we are going for serverless. That's all for today. And thank you so much for having me. Thank you.
That's brilliant. Thanks very much, Sheen. Very, very comprehensive. We've only got a couple of questions, but I think we've overrun a little bit. So if you can answer those offline, that'd be great. There have been a few requests about articles for blogs or links to articles and blogs that you've written. So we've put your Medium link in the chat function. So
Sure.
if you've got any other links for everyone, if you want to chuck them in there, that'd be great. But yeah, thanks a lot, Sheen.